Today we're talking about electric field. So we've been talking about charged objects, and we've been talking about how this force, this electric force, is a field force. Well, we need to recognize then, if it's a field force, every charged object has an electric field. In our class, we're only going to be considering the field strength of one charge at a time. So, look at my little illustration here. As Bob gets closer, how will his readings change on his electric field ohmmeter? And if you're thinking to yourself that as Bob gets closer, his field is going to get stronger, because electric field is a distance-based thing. So what I've done is I've opened up a simulator called Electric Field Hockey. And I don't know if you've ever used the PhET simulators from University of Colorado. This is one of those. So what you see here, because it's a hockey-based game, here's a goal, here's a positive hockey puck. And this positive hockey puck is what we call a test charge. It has very little charge itself, but it can help you see electric fields. And so that's what I want to do right here. I'm going to click on this button that shows the field, and I'm going to drop a positive charge in. And now you can see these arrows. What we're visualizing is the electric field of this red charge. And you can see that as you get closer to the charge, the arrows are darker because your electric field is stronger as you get closer. And the other thing I want to see is when we drop this negative in, now look, again, distance. But look, the electric field lines go from positive to negative. Now, what's going to happen is these arrows here represent the force acting on our hockey puck. So if I release it, it's going to go flying off like this. Start. See, it's going to go flying off like that. Reset. And the only reason we're doing this is just to show how does a charge behave in an electric field. It's going to follow electric field lines. So this positive charge will follow the electric field line if we let it here. Start. Yay, we scored. How much fun is that? But that's just, I want you to visualize what electric fields look like. And obviously, if we bring in more charges, you can see that the positive field is getting stronger because we're making this charge bigger. So go ahead and stop that. So that's Bob's electric field ohmmeter. So here we are. Electric field strength comes with the variable E. It can be measured by taking the electric force between the charge that you're measuring and the test charge you're dividing by. So E is our electric field, force electric, between the test charge and the charge you're measuring. So that would be taking the force between the puck and the red charge in the previous page. Now, let's do a little substitution. Here, so ignore, give me a sec, ignore this for a second. Coulomb's constant equal Coulomb's constant times charge 1, which would be like our red puck, test charge, and the distance between them. That's your electric force equation. But then we divide by test charge. That's this guy here. Now, you can see mathematically that these two are going to cancel each other out, leaving us a new equation here. Electric field equals Coulomb's constant times charge 1 divided by the distance between them squared. So the electric field strength, it doesn't take into account the test charge itself. It's only going to measure the electric field of the charge you're measuring. As you're writing things down, I would focus on writing down the first equation and the third equation, as this one is a step between. Now we're going to do a sample problem. Hold on a second. So I quick grabbed the numbers out of the sample problem, and they gave us in this corner a 7 microcoulomb charge, and in this corner a 5 microcoulomb charge. We're told that point P, the place we will be measuring from, is up here. It is 0.4 meters up the y-axis, and it is 0.3 meters down the x-axis. Now, using your simple geometry knowledge, I think you can see it's a 3, 4, 5 triangle. So when we do our electric field, we're going to use the E equals K times Q over D squared. So let's type this stuff out here. Electric field for number 1, that's this 7 Coulomb charge guy here, number 1. And this is number 2, our 5. Electric field for number 1 is going to equal Coulomb's constant times 7 microcoulombs, 7 times 10 to the negative 6th, right? 7 times 10 to the negative 6th coulombs. And then we want to divide that, space, divided by the distance squared. So for charge 1, our distance is 0.4 meters. So I'm going to throw a parenthesis in there, 0.4 meters. And we want to square that. Oh, I can do a superscript here. We want to square that little guy right there. And what you're going to do then is you're going to work through that calculation. And you're going to see that this comes out to, here, pause it while you calculate, because I actually want you to actually sit and calculate this. This one comes out to 3.93 times 10 to the 5th, and that is newtons per coulomb is your unit. Now, then they ask you to repeat the problem for the other charge. So let me just take this, work. There's number 1. Now let's just substitute. This is the electric field for number 2. This is a negative 5 charge. And the distance is 0.5 meters. And the answer, of course, will be different. So take a second and calculate that. Feel free to pause the video while you calculate it. And the answer is going to come out to 1.8 times 10 to the 5th newtons per coulomb. Now, is there a negative right here? There is. But if we're just talking about the strength of the field, you're not worried about that sign. In reality, this sign will make the direction of the field different. Whereas at point P, the field would be measured as going, I suppose, let me grab an arrow real quick. I suppose it'd measure it as going towards that P, and over here it's going to measure it coming away towards it this way. Not a focus of ours. If you can tell me the electric field strength, we're good. So here you go. You're on 565 as your homework. It's 1 through 3. In number 1, they give you an extremely similar question to the one we did just now. Just find the individual electric fields. Don't worry about combining them algebraically. Other warnings I need to give you. In number 2, they're talking about protons and electrons. We learned back in chapter 16 the charge of a proton and the charge of an electron. And in number 3, kind of the same deal. They give us electrons and protons. Those are charges. 1.6 times 10 to the negative 19th is a very important number.